So we're going to start day 2 here, and we're going to, on day 2, focus on arithmetic sequences and series. So again, our sequence is the list of numbers. And what a series is our sum of the sequence. And what arithmetic is, I'm going to write let's say if we have 2, 8, this would be an arithmetic, and another one would be, let's see, 5. Well, you'll probably notice right away, all of these have a common difference. We add 6, we add 6, and we add 6. This one we're adding 2, 2, and 2. That's what makes it arithmetic, that common difference. Now, if we were to write this formula for this, we have to add 2, but how do we get this first term? What do we add 2 to? Well, to get the first term, we'd have to add it to -4. So our sequence would be -4 plus 6n. Because to get our first term of 2, we'd add 6, but we have to add it once to -4. We have to add it twice to 8. So to get this one, well, what would we have to add 2 to? Well, we'd have to add it to 3 once. So it would be plus 2n. Now, quite often, let's see. Whoa, sorry guys. Quite often you'll see a formula for that. Well, let's see. Whoops, let's try this one first. So the 41st term. Well, what are we doing? We're subtracting 7. But to get the 41st term, how many times would we be subtracting 7? You'll notice to get to the 10th, this number 10, or our 4th term, we only subtract it 3 times. So to get to the 41st term, we'd start with 11, or we could think of it as adding -7, or subtracting 7, I should say, or add -7, either one works, but you have to subtract it 40 times. So, and let's see, what do we have for 11 minus 7 times 40 gives us -269. Now, you'll often see a formula for this. Well, here's some definitions of arithmetic first. Fixed number, here's the explicit formula. To get any term, and this is just what we figured out on this last page. You take your first term, and you apply that common difference one less than the term you want. So this one, we applied that common difference. We wanted the 41st, so we'd apply it 40 times. So as you can see here, this one would be 11 plus 40 minus 41 minus 1 times -7. And we should end up with that same thing. And then we talk a little bit about recursive here. Relies on the previous term to find the next one. And we went over this yesterday, but you'll notice here we're using the 2 previous. So if we have 3 and -4, it says to get to the next one, you add the 2 previous. So 3 plus -4 is -1. You have the 2 previous, and we get -5. The 2 previous, and we get -6. And we could keep adding those there. Now, this next one here, given the sequence, show that it's arithmetic. Well, let's show this. Well, each time we're adding 7. Find the formula for the sequence. So some of you might like to use that formula we were given, a sub 1 plus n minus 1 times your difference. So a sub n equals 2 plus n minus 1 times 7. And if we distribute there, 2 plus 7n minus 7, so we have -5 plus 7n. And you might recognize that, well, what number do we have to add 7 to get our first term of 2? That would be -5. And then the 100th term, so a sub 100, our 100th term, would be -5 plus 7 times 100. Or you could fill it in the blanks to this top one. You could say our 100th term equals 2 plus 100 minus 1 times 7. So 2 plus 99 times 7. So we get negative, or 695. Really, I didn't need the calculator for that. Looking at this one here, 7 times 100 is 700 minus 5. So let's take a look at this one. In an arithmetic sequence, the 9th term is 48, the 12th is 75. Find the first term and common difference. So again, I'm going to write down a sub 1 plus n minus 1 times our difference. That's our arithmetic formula there. So our 9th term is 48. So we know 48 equals a sub 1 plus, well, our n value is 9 minus 1 times d. So if I simplified this, I'd have 48 equals a sub 1 plus 8d. And this next one, 75. 75 equals a sub 1 plus 12 minus 1 times d. Simplifying that, 75 equals a sub 1 plus 11d. Well, we have this system here we could solve. So I'm just going to multiply this one by negative 1. So we have negative 48 equals negative a sub 1 minus 8d. 75 equals a sub 1 plus 11d. Add these together. So we have 27 equals, that's gone, 3d. So d would have to be 9. And let's see, now we need to find our first term. Well, we know 71 equals a sub 1 plus 11 times 9. So 75 equals a sub 1 plus 99. So negative 24 equals a sub 1. And I would double check these, and I would plug this in. Does 48 equal negative 24 plus 9 minus 1 times 9? So does negative 24 plus 8 times 9? Yep, that works on that one. That gives us 48. And let's check this other one. Does 75 equal negative 24 plus 12 minus 1 times 9? So we have negative 24 plus 11 times 9 and 75, so we're good to go. So let's take a look at this next example here. We have these values here, and find k given that they are consecutive terms in an arithmetic sequence. So let's see, 3k plus 1, k, and negative 3. So we're adding some sort of difference here to get that value. So we know 3k plus 1 plus d equals k. And what else do we know? We know k plus d equals negative 3. Let's see, what if I was to simplify this? 1 plus d equals negative 2k. Well, I could solve for k here, minus d. So k equals negative 3 minus d. So I could plug that in. So I know 1 plus d equals negative 2 times negative 3 minus d. 1 plus d equals, let's see, that would be 6 plus 2d. d minus d. 1 equals 6 plus 1d. So our difference is negative 5. So if this way is going down negative 5, we must add 5. So let's see. So if we add 5, let me see, 3k plus 1, k, and negative 3. So if we know this is negative 3, this has got to be 2. And that would be 7. And does that work? Yep, we're going down 5 each time. So our k value is 2. Find the formula for the nth term given the third term is 8 and the 8th term is 17. So this is similar to one that we've done already. We're going to use this idea, that a sub n equals our first term plus n minus 1 times our difference. So we know our 8th term equals our first term plus 3 minus 1 times d. So 8 equals a sub 1 plus 2d. And negative 17 is our first term plus 8 minus 1 times d. So negative 17 equals a sub 1 plus 7d. Multiply one of these by negative 1. So we have negative 8, negative a sub 1 minus 2d. Add these together, negative 25 equals 5d. So our difference is negative 5. Plug that back in here. So plus 35. So we have a sub 1 equals 18. So our formula would be 18 plus n minus 1 times negative 5. All right. So the next thing we're going to take a look at here, find the number of terms in a sequence. So similarly, we're going to use this. We want to find our n here, but we know our difference is negative 3. So we know our 12th term, and we know our first term is 84, plus n minus 1 times negative 3. We can distribute here. So let's see, minus 84. So negative 72 equals negative 3n plus 3. Negative 75 equals negative 3n. So there must be 25 terms because our 25th term would give us 12. I'm going to pause this and then you can start part 2.